Today we're going to be talking about section 4.4, which is on complex numbers. Now, complex numbers are made up of real numbers and what are called imaginary numbers. And imaginary numbers are denoted by the letter I. Okay? I is for imaginary. And what I is equal to is the square root of -1. And so this is where, when we would look at quadratics and they would have no real solutions, it's because they had imaginary solutions. They had complex answers. So, one thing we can talk about is that if we have the square root of a negative, let's say a number b squared, okay? Well, what we can actually break it down to is the square root of b squared and the square root of -1. Well, this is just I, and the square root of a square number is just b. So my solution is the answer bi, where b is some number, okay? So we can look at an example right here having square roots of negative numbers. Now if I look at number or letter A, okay, square root of -27. Well, I want to think of all the factors of 27, any of which that are squares, okay, squared numbers. So I'm going to think of it like this, okay, well for sure I have -1 times, okay, and what are the factors of 27 that any of them are squared numbers? 9 is one of them, and it's 9 times 3. So this is the same as the square root of -1 times 3 squared times 3. So we can rewrite it as square root of -1 times the square root of 3 squared times the square root of 3. Well, the square root of -1 is just I, the square root of 3 squared is just 3, and the square root of 3 remains the same. So my solution then is 3i square roots of 3. So the square root of -27 is 3i square roots of 3. Now look at letter B, okay? Square root of -216. Well, first off, I know that -1 is one of my factors. Then I think of other factors of 216. Well, if I divided 216 by 2, that would be 108. Well, that's not a perfect square. If I did it by 3, that would be 72. That's not a perfect square. If I did it by 6, that would be 36, which is a perfect square. So I can write it as 36 times 6. So obviously that's going to be then the square root of -1 times 6 squared times 6, which is the same as the square root of -1 times the square root of 6 squared times the square root of 6. This is really just I, this is really just 6, and square root of 6 remains the same. So I get 6i square root of 6 is my answer. Here are 2 guided practice problems that you can try as well. Now, the commutative and associative properties of multiplication also hold true. So this is what happens, okay? If we have I to the first power, just I, that's going to be I. I squared is square root of -1 times square root of -1. Well, a square root of a -1 is just going to have the squares cancel out. It's equal to -1. Then I to the third power is the same as I squared, which is -1, times I, which is just -I. And then finally, I to the fourth is -I squared. Negative times a negative is positive. I squared is -1 squared, so that's just going to be 1. So here are the rules, and we can continue on. I to the fifth repeats itself, goes to I. I to the sixth is the same as I to the fourth, which is 1 times I squared, and so on and so forth. So we're trying to figure out what each one can be. So let's simplify using those properties of imaginary numbers. So the first one, -5i times 3i. Okay, well, -5 times 3 is -15. And then I times I is I squared. Well, -15 is just going to be -15, and I squared goes to a -1. So we really have -15 times -1, so my answer is positive 15. Let's look at letter B. Now, for letter B, we need to start by taking care of each one individually, okay, each one of these square roots? Well, the square root of -6 is really I square root of 6 times square root of -15 is really I square root of 15. So what we're going to do first is multiply the i's together. And so I times I is I squared. And the square root of 6 times the square root of 15, okay, is going to be square root of 90. So what we can do then is we say I squared is really just a -1. This is -1 times the square root of 90. Now what are some factors of 90 that are perfect squares? Well, the first one that comes to my mind would be 9 and 10. Now I'm not going to write it out like I did in the last couple examples, but you know that 9, the square root of 9, is really just 3. And the square root of 10 is going to remain square root of 10. So what I end up getting is -3 square roots of 10. Here's a couple guided practice problems. I'd like you to try 2C. Now break it down into factors of 4, because I to the 4th so many times is also going to be just 1. So break this one down and figure out what our I to the 31st power is going to be. Now, we can use what's called the square root property to solve some quadratics looking like example 3. Now, there are two ways to solve this, so I'll look at both ways. The first way is a little bit easier. X squared plus 64 is equal to 0. I subtract 64 from both sides, and now I get x squared is equal to -64. Well, how do you get x by itself? You square root both sides. And so you get x equals, now just like normal square roots, you can either have positive or negative answers. Okay? Now the negative is what's going to give us an I, and then the square root of 64 is going to be 8. So my two solutions are plus or minus 8i. The other way we can do this is by saying, here's my equation. X squared plus 64 equals 0. And I can take the square root of both of them and set it up like this. Well, the square root of x squared is just x squared. And then plus the square root of 64 is just 8 squared. Now, we want it to be in the form x minus something. So I could do x squared minus -8 squared. And the reason I do that is because now minus and negative is the same as adding, right? And so I can write it then as the square root, well, the square root of -8 squared is 8i. So I can write it as x plus 8i times x minus 8i equals 0. And then I can solve each one. So you'd say x plus 8i equals 0 or x minus 8i equals 0. And we find both ones to be 8i or -8i. So we get the same answers both ways, but I would still say probably the first method is a little bit easier. Here's two guided practice problems that you can try right now.